again, here we are. Notes constant of proportionality 2-3. We're looking at this word proportionality, really focusing on proportions for this entire topic. In our key concept box today, we have recall that two quantities x and y have a proportional relationship if y is always a constant multiple of x. This constant multiple of y divided by x is called the constant of proportionality. If x and y have different units, then the constant of proportionality can be written as a unit rate. I've highlighted those three things specifically, the y divided by x, the constant of proportionality, and unit rate, because they all mean the same thing. Y divided by x, constant proportionality, and unit rate. Whenever we are talking about those three things, and we'll learn yet again another name for it later on, is they're talking about the same thing. And it gets really confusing because they can ask you to write it as a ratio, they could ask you to write it as a unit rate, and they could ask you to just say what is the constant proportionality. So if we're looking here, there are 5 bricks, and they're showing that the total length of the 5 bricks is 100 centimeters, which they're showing us right here in this chart. What they have now done is gone through and shown us that if you take the total length in centimeters and divide it by the number of bricks, I just started that thought again. You take the total length, divide it by the number of bricks, you're going to get a ratio of 20 to 1. So when you take 100 fifths, 100 divided by 5 gives you actually 20. So what they're showing is that if you now have only 4 bricks, 80 divided by 4 will give us 20. What I want you to notice is that the chart is given to us horizontally instead of vertically. So this is our x, this is our y. And when they set up the comparison of the two, notice that total length would become the y and the number of bricks is the x, which goes back to y divided by x. So it goes on to say that the constant of proportionality is 20 centimeters per brick, which they could also say the unit rate is 20 centimeters per brick, because the second unit right here would be 1. So example number 1 states the weight of the stack depends on the number of books in the stack. Obviously, if you have more books, heavier the stack, less books, the lighter the stack. They would like us to identify the constant proportionality for this situation, and then use the constant proportionality to find the weight of 11 books. So this is very similar to what we've already been practicing in topic 1. They want us to find the weight per book because the weight per book would be the constant proportionality. The weight is given to us right here, and that's 15 75/100 pounds divided by 9 books, coming from, if I count up the stack of books, there are 9 books there. When I would divide these, I get a unit rate, which we've learned that the unit rate is also going to be the same thing as our constant of proportionality. And I'm going to call the constant of proportionality the COP. All right. Now that I know the unit rate, or I know the constant of proportionality, I'm going to take that constant of proportionality of 1 75/100 pounds per book. If I know how many books I now have, I multiply that by 11 books. I can cross cancel my units of book, and I will get 19 25/100 pounds. And I have a spot for us to write those answers right here, constant proportionality, 1 75/100 pounds per book, and the weight of 11 books, 19 25/100 pounds. Question number 2 says that the table shows the amount of money raised based on the number of tickets sold for a charity concert. So A is asking, does the table show a constant proportionality? So again, thinking about constant proportionality is the same thing of y divided by x, or a unit rate. If so, what is the constant proportionality for this situation? Notice we've got tickets sold, which would be our x, and money raised, which would be our y. If we're comparing our ratio of y divided by x, notice that the money again goes on top. students were asking previously, do I need to show all the ratios? Yes. We have to show all of the ratios that are given to you in this chart. So we take the 3,600 divided by the 160 tickets, and I'm going to get $22.50 per ticket. In order for this table to show a constant proportionality, I have to show that proportionally the tickets sold to the money raised is equivalent. So I go through, the next amount of money raised is $11,250 divided by 500, and again I will get, sorry, $22.50 per ticket. We'll just finish out those remaining two with each other, so we get 16,875 divided by 750, which will give us again $22.50. Sorry, I'm writing over the chart. And then the $36,000 for 1,600 to again give us $22.50. So does this table show a constant proportionality? Yes. What is it? $22.50 per ticket. So again, when you see that word constant proportionality, kind of replace it with the word unit rate. Part B then goes on to say you can sell no more than 2,500 tickets for the concert. Find the maximum amount of money the fundraiser can raise. Well, if we can only sell 2,500 tickets, and we now have our unit rate of $22.50 per ticket, I take my unit rate, multiply it by the number of tickets that they're planning on selling. Again, I can cross-cancel those tickets to now leave me with the amount of money, which would be $56,250. I'm going to have you guys flip the paper over and try number 3 on your own. When you resume the video, it'll be ready for you. Even though this one is multiple choice, I'm still showing that all of my rates do come down to 8 seconds per gallon. And if I wasn't sure about which one needed to be divided by which, I can look to what the labels are saying in my choices. But also, this is your X, this is your Y. So Y divided by X would be the time divided by the gallons. Number 4, you have a little graph here. It says it shows the number of times a male hummingbird beats its wings based on time. What is the constant of proportionality for the second, or excuse me, for this situation? And then B, what does the 0.180 represent? So the constant of proportionality, again, we're really saying to ourselves, is the same thing as a unit rate. This is nothing new for us. The unit rate, meaning, I'm going to show my work here, the unit rate, if I'm talking about Y divided by X, I want my X to be 1. So I look at my graph, and I'm looking on the X-axis when I have 1. And where I have 1, I will go up until I hit my line, and I go over, and I hit 80. So when the time is 1 second, the number of beats will be 80. So the unit rate would be 80 beats per second. So then B, what does the 0.180 then represent? Well, 180 would be exactly the point that I plotted right here. It would be the unit rate, 80 wing beats for every second. Go ahead, take a look at number 5. Again, when you resume the video, it'll be ready. So we have a correct answer here of 20 kilometers per hour. I'm just showing you on the right that if, again, we're thinking of our ratio Y divided by X, our Y is being measured in kilometers, and our X is being measured in hours. So if I have kilometers per hour, again, constant proportionality is the same thing as a unit rate, so I want this unit to be 1. So on my graph, when the hour is 1, what will the kilometers be? 20. So that's why I'm getting 20 kilometers per hour. I successfully finished my video in almost under 10 minutes. Thank you guys for watching. Again, we will see you tomorrow.